I'm Sam Rikard. I'm a meteorologist. Now, what does a meteorologist do? A meteorologist studies the science of weather, makes weather predictions, makes short-term and long-range weather predictions. Why is weather important to you? Weather's important to you because you want to know what you need to wear today. You want to know if you need an umbrella. Is it going to be cold? Is it going to be hot? It's important to young people. It's important to people who are much older. It's important to adults. We're going to talk about a lot of things today. I'm going to talk about different types of precipitation, what it takes to make it snow, what's the difference between sleet and hail. We're going to talk about weather symbols on a weather map. We'll talk about different types of storms and the different tools that a meteorologist uses to predict the weather. In fact, I'll give you a tour of my weather studio in just a few minutes and also tell you how I prepare a forecast. So, are you ready to get started? I certainly am. Here's the first thing we'll look at. This is a weather sensor that has multiple components to it. It's one that you could buy and put in your backyard, and you would know the weather conditions at your home. I have several of these at the weather station here at the weather studio. First thing we'll point out on this sensor are these little cup-looking things right here. This is called an anemometer. An anemometer starts to spin as air moves or as the wind blows through it. The faster and faster the wind blows, the faster and faster these cups spin round and round, and that sends signals to a display inside my office to tell me how fast the wind is blowing. Now, it's important to know what direction the wind is coming from also, and that is determined, or that is shown by this. This is a weather vane. It points in the direction that the wind is coming from. So if the wind is coming from the north, that is pointed toward the north. Now, rainfall, we need to know how much it has rained. It's very important to know how much it has rained with any type of storm. Rain falls inside this device, inside that cup, and it is measured, and that signal is sent inside to the display also. Now, this bottom component right here, this is where the temperature is determined, and the dew point, and that's the amount of moisture in the air. So as it gets hotter and hotter, this thing signals inside and tells us what the temperature is. In fact, simply put, that's a thermometer that's hanging on this weather suite. Now, the device I was talking about that records all of this information and displays the information inside the Weather Center office is this. It tells you the temperature, the indoor humidity, the outdoor temperature, the outdoor humidity, how much rain has fallen today, wind direction. At this point in time, winds blowing at 1 mile an hour from basically the north-northeast. Barometric pressure, the barometer, the amount of air pressure that's in the air, read right here, 29.90 inches of mercury. And this tells you how much sunlight is outside, 324 watts per meter square. Now, I know you probably don't understand that, but that means the sun is shining fairly brightly outside. And the UV index, you need to know that if you're going to be outdoors for a long period of time, because if the UV index is high, then you'll get sunburned really, really quickly. If it's low, then it takes longer and longer. 3 is fairly low. It's called the moderate scale. So let's move forward with this lesson to the next segment, and we're going to talk about the seasons of the year. Now, I know you know what the seasons are. There's spring, summer, autumn, fall, and winter. Now, the warm seasons of the year, that's spring and summer, when we have longer days and shorter nights. The sun doesn't set until 8:30 or so in the evening in the summertime. And that's when the crops are growing in the fields. Farmers grow their crops during the warm season. Now, our cold seasons, fall and winter here in the northern hemisphere, that's when we have shorter days and longer nights. Now, around Christmas time, the sun sets around 5 o'clock. We have about 6 or 7 hours less daylight at Christmas time than we do in the middle of June. Now, why do we have seasons? Some people might say that it's because in the summertime we must be closer to the sun, and in the wintertime we must be farther away from the sun. That would make sense, right? Well, that's just not the way it is. Seasons on Earth are determined because the Earth is not just straight up and down. If you look at a globe, and I don't have a globe here to show you, but if you look at a globe, you see it's tilted. That axis is tilted at 23.5 degrees. So the side that is closest to the sun, that's where the warm temperatures are. The side that is further away from the sun or tilted away from the sun, that's where the cooler temperatures are. And to be exact, in the wintertime here in the United States, we're actually closer to the sun than we are during the summertime, but in the wintertime, our part of the earth is tilted away from the sun, and that's why we have colder temperatures. The equator, that's where the hot temperatures are year-round, all year long. And then at the very top of the earth and the bottom of the earth, the North Pole and the South Pole, that's where it's cold all year long. Now, precipitation. What is precipitation? Basically, precipitation is anything that's water-related that falls from the sky. Now, what the most common form of precipitation that we have here is rain. And we can have light rain and heavy rain. Rain comes from clouds. Now, what is a cloud? A cloud is just water molecules that are almost ready to condense, and they're grouping together through the sky. You can have little white fluffy clouds that you see floating by in the summertime, and they can develop into thunder clouds, and you can have clouds covering the entire sky. And once the water molecules there begin to stick together enough and become heavy enough, they fall to the earth as rain. Now, snow. We all know what snow is. We don't see a lot of that in the Mid-South, but snow forms high in the atmosphere where it's very, very cold and then falls all the way to the earth. Sleet are ice pellets that started out as snow, fell to the earth, melted, and then refroze as little pellets and before they hit the earth. And then, of course, hail is formed during a thunderstorm, and there's another thing called freezing rain that we'll talk about. We'll look at this a little more in depth right now. And consider these orange areas as warm temperatures and the blue areas as cold temperatures. In order for it to snow and for it to fall all the way to the earth and stick and accumulate, the temperature has to be below freezing, all the way from the surface of the earth all the way up, high up in the atmosphere. So this snowflake falls through cold air, never ever has the chance to melt at all. Sleet, little bitty ice pellets that hit the ground and bounce around. They're fairly small pellets. They start out as snow. They fall through a warm band of air and melt, but then they fall through an area of air that's much, much colder and below freezing all the way down to the surface of the earth, so that snow melts into a raindrop. Then it refreezes as little ice pellets and hits the ground and bounces around and can cause slick roads and those type of things. They don't cause a lot of damage to utilities and all, but certainly can make the roadways dangerous. Freezing rain. A lot of people get it mixed up between sleet, freezing rain, and basically rain and hail. But anyway, here freezing rain starts out as snow. It's colder than freezing, high up in the atmosphere, falls into some warm air and melts into raindrops. But just before it gets to the ground, the air at the surface is below freezing. So when that raindrop hits a car or a sidewalk or a tree or your house or the grass, then it freezes into ice again. And that can cause a big, big mess. Can cause some very slick roadways, slick sidewalks that you have to watch when you walk on, or you might slip down, and causes damage to trees also. Now, plain old rain, that starts out usually high up in the atmosphere as a snowflake. That's unusual. We probably don't think of that, but a lot of times it starts out as a snowflake, but then falls into warm air that's warm all the way down to the earth's surfaces, so it ends up just being a raindrop. And that's what's most common here in our area. Let's talk about a weather map. Meteorologists on TV use these weather maps to show you what's going on where and what you can expect. So we're going to slowly walk through the different symbols on this weather map. We'll first start with the little numbers. These numbers indicate what the current temperatures are at the surface at all of these locations across the United States. So if you look closely right now, down in Florida on this map, temperature is in the 70s. It's in the 50s in the Mid-South, in the 40s up in the Midwest. In fact, you see a few 30-degree temperatures in the mountains of the West. Now, this blue line right here with the little pointy things on it pointed this way, we call that a cold front. Now, fronts on a weather map, all they are doing is separating different types of air masses. And in this case right here, you have warmer air here, and you have cooler and drier air up here. This air is moving in this direction, in the direction of these points, and that's called a cold front. Now, cold fronts are what usually cause thunderstorms to develop and you can have some strong thunderstorms out in front of it. In the wintertime, cold front moves through all the way down into our area. We'll have thunderstorms in front of it, and then behind it there may be some snow or some sleet falling. Now let's look at this right here with a different color lines right here. This basically separates air masses, a cooler air mass here, a warmer air mass here, but it's not really moving. It's not really moving either direction on the map. That's called a stationary front. And if we had a line that had just these red symbols on it, draped across the U.S., that would be warm air moving in the direction of the side of these little emblems, whichever direction they are placed, they are on the map. So we have cold fronts and stationary fronts, and we have warm fronts, or the predominant fronts that we talk about on the map that are basically separating air masses as they move across the country. This L right here, we have several L's. These are low pressure systems. Low pressure systems are generally associated with rain and clouds, and that technically is where the pressure is lower, air is rising. It takes rising air and moisture to create showers and rainfall. Those are low pressure systems. The exact opposite of that, a high pressure system, where the air is basically sinking and getting heavier, is indicated by this blue H. High pressure systems generally are associated with nice weather, maybe partly cloudy skies, maybe clear skies and sunny skies. So high pressure systems bring good weather most of the time. Low pressure systems bring rainy weather and stormy weather in a lot of cases. Down here we have a little white emblem right here. This is basically, it's called a cone. That's basically where a hurricane might be possible on this particular weather map. So weather maps are important, especially to a meteorologist. They're important to you as you watch it on television, so you can see what weather is headed in your direction. And now that you know what a cold front, a low pressure system, and a high pressure system, and a stationary front are, you can understand better what the weather person is saying on the television. Now, there are other tools that are used. Weather people use maps to show where there's risk for severe storms and other type of things. We're going to talk about another subject in just a moment. One other tool that I meant to talk about is called a microsonde. Now I'll get a little closer. Maybe you can see that right there. It's called a microsonde. And do you like to play with balloons? Well, if you want to be a meteorologist, they play with balloons about every day. In fact, I'll talk about this for just a moment and tell you exactly what it is. This device is attached to a helium balloon. Now, it's a fairly large helium balloon. They put helium in it because helium is lighter than the air around you, and it would cause this to float up in the air. And I'm sure that you have seen balloons that you can let go and they float up in the air. Well, that's what meteorologists attach to this. Now, this balloon gets larger and larger as the air pressure around it gets less and less, and the air pressure inside the balloon expands. And this takes this device to way, way up high in the atmosphere, sometimes 30 or 40,000 feet, like 5 or 6 miles up in the air. And this component has multiple weather instruments inside it. It will send back to meteorologists what the air pressure is, what the wind speed is, what the temperature is, and what the dew point is high up in the atmosphere, because it's very important to a meteorologist to know what the different conditions are up above us, because that certainly impacts the weather that will be down below us. So as we talk about this instrument, this is important. This is a manual way of determining weather conditions above us, but how do we look at weather conditions in other methods? We have satellites that fly around the Earth all of the time and take pictures of the Earth's surface. Now I'm going to put this down and be right back with you. Here we go. This is a satellite map. Now, these white things right here, these are clouds on top of the U.S. Clouds in Florida today. There are light, thin clouds across Ohio and Pennsylvania, up in the Great Lakes, and some thicker clouds along a cold front from Billings to Rapid City up into Minot, North Dakota. Now, how did we get these pictures of clouds? Satellites that are high up above the Earth's atmosphere in outer space take pictures constantly of these clouds. And what's important to a meteorologist too is where are they moving? So I'll put that in motion, and you can see these clouds are moving to the east. These clouds moving to the northeast, not moving much at all. A few little clouds down in central Mississippi when this was taken, and a few clouds over off the coast of California. Now, what's important to a meteorologist is to know how these are moving, and he or she would know that clouds will move into Wisconsin and into Michigan later on today. So that is very, very important. I'm going to walk you through a few weather scenes and explain those things to you as to how a weather meteorologist on TV uses those. Right now we look at the local radar. Nothing showing up on this radar right now. As I put it in motion, you can see nothing moving, but if there were rain or if there were storms in the area, then we would see yellows and greens and reds and all those things, and we'd see them moving closer and closer to us and maybe even away, and that would tell us what we can expect in the near future. Now, this map is generated by a computer model. That is another tool that meteorologists use. Now, there are numerous computer models that a meteorologist will look at just to see what the computers think the weather is going to be like in the future. Some models only predict the future for the next day and a half. Other models predict the future for the next 8 or 10 days, and maybe even longer than that. This model shows that in this instant that it is expected a high-pressure system to be there, cold front across Georgia and the Carolinas, and some rain in West Virginia, some rain down in Florida. It moves it forward 12 hours or so, and then we move it forward even further than that, and you can see the rain is moving off the coast of the Carolinas. Very important to a meteorologist to know what the models believe the weather's going to be like. It's the meteorologist's job to interpret the models. As I said, there are multiple computer models. There are 4 or 5 that I look at just about every day, but there are 25 or 30 different computer models that a meteorologist could look at any point in time. Of course, we give you the 7-day forecast, and this forecast is not valid for today while you are watching this, but I just wanted to point out some of the symbols on this. On a typical 7-day forecast, these numbers with the percent signs by them are basically telling you the chances of rain that day. And of course, the sunshine and the clouds tell you what the sky conditions will be throughout the day. In this case, we're expecting 5 straight days of sunny skies and then some partly cloudy skies, and then the sun's coming back. Yellow numbers here, those are the forecasted high temperatures for the day. The white numbers are forecasted low temperatures for the day. And this is just another weather map, weather graphic that I'm showing you the same thing. I'll be back in just a moment with other news about weather. Now, I just showed you a lot of weather graphics on a weather map. I showed you the national map and all the low pressure systems and the cold fronts and all the different things with the temperature on it. And I showed you the 7-day forecast, and I kept pointing to things like this. Well, this green wall is what is actually behind me. There are no graphics behind me. There's just a green painted wall behind me. The computer knows that if it sees green, to put the graphics on it. Now, how do I know where all of those graphics are if I'm just looking at a green wall? Well, you see this television set right over here, and on this other side, another TV set right there. That's what I'm looking at, and that's how I know where to put my hand on the national map. Now, I'm going to reverse this and show you what I'm actually looking at straight ahead if I'm doing a weather forecast for everyone, and this is what I'm looking at. Right here is the camera that is recording everything. This is another big screen TV. That shows me also where I am on that weather graphic. And of course, right here over my head, that's a bright light that I turned off for this photograph. I have another computer off to the left of me and another one off to the right of me. Those are the things that help me stay in the right position when I'm doing a video weather forecast for TV or for Facebook or YouTube. Now, all of the equipment behind this camera over here, all computer equipment with graphic capabilities. They all have the ability to pull in computer models and create those graphics for me. I was asked a question, how do I prepare a forecast? Well, I get up early in the morning hours and I first look at the current conditions. What is going on right now outside my door or outside the door for the area that I'm trying to make the forecast for? The skies may be clear, they may be cloudy, it may be cold, it may be warm, the wind may be blowing, but I need to know that as a meteorologist. I need to know what it's doing right now in order to begin to make the forecast for the day and for the week. The next thing I do is look at computer models. And I told you that I look at 3 or 4 just about every morning that I'm confident with. And sometimes those computer models agree, sometimes they don't agree. Sometimes they say storms may be coming through at, say, 10 o'clock in the morning, and the other computer model may be saying 2 o'clock in the afternoon. That's where a meteorologist has to use their own analysis ability to come up with a forecast and determine what the meteorologist believes is actually going to happen. Sometimes the computer models don't agree with the high temperatures or the low temperatures. They don't agree if the clouds are going to stay or they're not. And the meteorologist has to use his local analysis abilities to do that. So I look at the current conditions, I look at computer models, I actually read the National Weather Service scientific observation to see what those people think it's going to do, because I think those people at the National Weather Service, they're probably the best in the business. Now let's talk about storms. Storms are important. Storms can scare you at times. I don't think you need to be scared of storms at most times. You just need to know what you're going to do if a storm comes through your area. Well, let's start out with just regular rain. You know, rainfall just gets wet and makes things wet and makes things slippery outside. Freezing rain makes things dangerous to walk, makes power lines heavy and tree limbs heavy, and could make those break. Snow, fun to play in. It's a mess to clean up after, but it's fun to play in, even though we don't get it here often. It causes the roads to be slick just for a few hours, mainly in this part of the country, maybe just for a day or two, and there's nothing really to be concerned about that. Severe thunderstorms, tornadoes, and maybe hurricanes are more important. Hurricanes important if you live along the ocean areas, along the coastal areas of the Gulf Coast. You certainly need to know about hurricanes, but hurricanes give you a lot of advance notice. You know 3 or 4 days ahead of time whether a hurricane is going to come in, and you can take care of things at your house, and you can move on somewhere else and avoid the hurricane altogether. Severe thunderstorms and tornadoes are much more difficult to predict as to when they're going to occur and what exactly is going to happen and what specific areas are going to be impacted. So if you have a severe thunderstorm warning, you just need to know that a warning means that a thunderstorm is in the area. The difference between a watch and a warning is this. A watch means that the weather conditions are right for a thunderstorm or a tornado to develop, but one has not been detected. A warning means that, yes, a severe thunderstorm is close to your area, or a tornado is close to your area. So what do you do if you're under a tornado warning? Well, you need to go to a safe place inside your house. And the best place would be a bottom floor, not the second floor, but the first floor, and inside a hallway away from windows. You don't need to be close to windows because a tornado can blow objects through the windows into your house. So a hallway or a bathroom that has no windows is the best place to be. My motto is don't be scared, be aware. That means don't be so scared of the storm. You can't do anything about it, but just be aware of what you need to do in case a storm is in your area. Now, how do you receive your storm notifications? That's a good question right there. Do you listen to the television for the meteorologist to break in and say there's a storm in your area? Do you listen to the radio for that? Do you have a weather radio in your house that makes a loud noise and goes off when there's a warning in your area? In my opinion, your mom and dad or your smartphone is the best way to receive storm warnings, because a smartphone knows exactly where you are, it knows where the storm is, and it can tell you whether a storm is headed your way. Now, another question I get a lot of time is, how do you become a meteorologist? I may have said earlier, when I was very, very young, I knew I wanted to be a meteorologist when I grew up. To become a meteorologist, you need to make sure you study a lot of math, a lot of science, and a lot of geography. If you want to point to the map that I was showing earlier, you need to know about geography, where the mountains are and how the mountains affect weather, where the oceans are and how the oceans affect weather, and you need to know where the land is also as you're pointing to where weather systems are. So you need to know where you are on the map, but you need to know science and you need to know math. And when you get into high school and to college, you need to take those more difficult math courses like calculus and maybe even trigonometry in college, and then you can prepare yourself to be a meteorologist for the National Weather Service, or you can go into broadcast meteorology. There are good colleges around that have broadcast meteorology schools and curriculum, and you could end up on television also as a meteorologist. Or if meteorology has just been a passion, it's just been something that you've really been interested in, study the math, study the science, study the geography. You can still go to school and learn about meteorology and learn more about what you've been so interested in for so long. I'm Sam Rikard. I hope you have learned something from this discussion about weather. If you have any questions, you can email me at weathermayor@gmail.com. You can watch my forecast on Facebook at Meteorologist Sam Rikard, or you can watch my forecast on Twitter at Weather Mayor. I'm Sam Rikard. I hope you've enjoyed this presentation.